Assalamualaikum ADP Part 2 Science students. I hope you are enjoying yourself and your studies through these online lectures. Today we are going to start chapter number 16, The Nature of Science, included in your syllabus. In this chapter, the writers, Rose and Hag, they have defined science. Basically, this essay is a chapter from their book, The Fabric of Science. And this essay is analytic, or this chapter is analytical in nature. Here, the writers have defined science. They have expressed their or they have begun their let's say their lesson or their chapter with their disagreement with the popular definition of science as an organized body of knowledge. Their objection, their reason being that if we accept this as a definition of science, then it would make cookbooks, scales, rubrics, catalogs, and telephone books science, which they are not. And they say that sometimes science is defined as only being rational, not this as rationality. They say that this popularly people say that science is rationality. Again, the writers do not agree with it. That they say that rationality is logical consistency, lack of contradiction. It is to be distinguished from reasonableness, fairness, the quality of mind open to arguments and evidence opposed to its beliefs, a willingness to consider. Rationality can be quite unreasonable or dogmatic. Rationalist metaphysicians and theologians are often certain about premises which come from intuition or revelation. That is, that science is not only rationality. Definitely, rationality means logical consistency, lack of contradiction, which is one of the elements of science. But to say that science is only rationality, it would make us confused. It would make us confuse science with other disciples, with metaphysics and theology, which are not sciences. Theology is basically science of God. It is something related to religion or faith, science of God, and it is not a science a science in the term we use the word science. Similarly, metaphysics is a science of mind. It talks about mind, and pure science is these are not pure sciences. So writers say that if we define science as only rationality, then the subjects like metaphysics and theology would also be considered as sciences, which they are not, because these sciences they take down their premises, their points, they take down their statements, which they derive from intuition or revelation. Revelation, and on the basis of these points, they form their theories, they form their ideas. So, science, according to writers, is not rational only. So, what is science? Well, students, according to them, science is four things at once. And what are those four things? These are empirical, science is empirical, science is rational, science is general, and science is cumulative. And it is all four at once. Now, empirical means based on experiment. Rational means, as I told you earlier, it means lack of contradiction, consistency, logical consistency. General and cumulative means increase or decrease by successive addition. Now, this is so they define science as science is empirical, rational, general, and cumulative, and it is all four at once. Then science is empirical. Then they discuss first science as being empirical. Now they say that science, the conclusions of science can be tested by experiments. Observation and experiments are important parts of science to verify or reject a theory. Okay, so it is observation made by qualified observers under controlled conditions all those things which confirm or disconfirm, verify or refute a theory. Over here, the writers have alluded to Sherlock Holmes. They have said that Sherlock Holmes could tell by looking at the stains on the clothes of a man, on dress of a man, what a man had eaten for breakfast. Okay, and how a particular crime was committed. Now, this procedure is excellent for detection but insufficient for science because it yields only knowledge of particular events. Science would go on to ask why and how crime, not a particular crime, but crime in general is committed. Science or scientific observation uses facts, and facts are used to test general theories and theories to make predictions about particular facts. So, why a crime has been committed and why crimes in general are committed. Okay, and then scientific observation. Now, so the purpose of scientific observation is to use the facts to arrive at general theories and from those theories to make predictions about particular facts. Now, the question arises over here: what are scientific observations based on? The writers, they say that the scientific observation may be based on things as they exist. For example, the color of an apple, the temperature of the air, or it may be made of what results from an experiment. Okay, and then the writers, they define experiment. An experiment is deliberate manipulation of conditions in order to bring about what we want to observe. For example, if we want to test hypothesis that a new plastic can bear 200 pounds of pressure without crumbling, without breaking into pieces, we may have to create a situation in which such pressure to a piece of the plastic, because it is unlikely that it is applied to a piece of plastic, but it is unlikely that situation already exists anywhere in the world, or if it does, that all other factors are kept constant. So scientific observation and scientific experiments, they are they are different from the ones done in other subjects. The writer talks about astronomy. He says that they say that astronomy we don't have sufficient enough control of the subject matter to experiment on it. Although we do control the conditions of the observation, we don't have any control on the movement of stars, which we try to observe in astronomy. But we have control over from where to observe those stars. Okay? Similarly, in chemistry, it is possible to to control the conditions of an experiment. Okay, so scientific observation will be made of things as they exist, or maybe made of what results from an experiment, and an experiment requires conditioning. Then the writers talk about science as being rational. Now, logic is consistently applied in scientific reasoning because it contains the rules of valid thinking. Although all scientific thought ultimately rests on observation, there was a vast portion of it which are certainly rational. Analysis of the meanings of terms, deductions from existent theories, exploration of the logical relations among concepts and among theories. Logic is applied to science consistently because logic contains the rules of valid thinking. Okay, so logic in science is rational, it lacks contradiction, there is consistency because logic is applied. Okay, logic is applied and it contains the rule of valid thinking. However, the writers and it is not based on intuition, it is not based on revelation. ठीक है, आपके अपने इंस्टिंक्ट पे डिपेंड कर रही है। साइंस जो है एक ऑब्जर्वेशन पे बेस कर रही है, एक्सपेरिमेंट्स पे बेस कर रही है, ठीक है। और इसका मकसद क्या है? फैक्ट्स से थीरीज बनाना, जनरल बात करना, और जनरल थीरीज से वो पर्टिकुलर फैक्ट्स जो कि वकूफ़ पज़ीर हो सकते हैं या होते हैं उनका बताना। फिर साइंस में एक्सपेरिमेंट्स होते हैं, एक्सपेरिमेंट्स ऑब्जर्वेशन से बेस करते हैं और उसके अंदर आप कंडीशंस को कंट्रोल करते हैं। जिस जिस चीज़ को आपने अपने टेस्ट करना है, सिर्फ उसको वेरिएबल रखते हैं, बाकी चीज़ों को कांस्टेंट रखते हैं, ठीक है। देन साइंस में लॉजिक अप्लाई हो रही है, इस वजह से ये रैशनल है। बट the writers over here make a statement. They say that though logic is applied, but it is erroneously considered that maths is the index or the status of any science. That we apply that mathematics, which is considered to be the language of sciences, it is mistakenly taken as the index of status of any science, which is not the case, or not. That is, it is considered that mathematics is the basis for all the sciences. Then the writers say that it is not the case. It is not all sciences are based on mathematics. There are sciences like biology. There are works by the scientists like Pasteur, Darwin, Pavlov, which are who have not who have used a very little mathematics. So nothing is gained by the use of mathematics when a subject is not measurable or sufficiently precise. Okay. Then science is journal. Now, if observation is the base of science, general laws are its crown. The body of any science is a set of general laws logically connected from which the occurrence of a particular event is predictable. Okay. So young sciences like 19th century biology are chiefly taxonomic. Taxonomic means that they are organized and classified in order for laws to be sorted. Okay, so science is journal. Then they say that the goal of science is the creation of a unified body of knowledge which will relate all the sciences to one another. So science is a set of general laws which are logically connected. Okay, they are not based on instinct, they are not based on impulses, what you or me like. They are based on logic, and from these the occurrence of a particular event is predictable. For example, if a chemical is heated, or if water is heated at 100 degrees Celsius, it would boil and convert from its solid state into liquid state. Okay. So, having said this, they say that the goal of science is the creation of a unified body of knowledge which will relate all the sciences to one another. Ideally, all sciences would be logically deducible from a single law, general enough to apply to everything. Yet, it is not achieved. So, they want to say that from the laws of physics, what is the goal of science? That from the laws of physics you could move to that of chemistry, or logically to the laws of biology or psychology and society. Okay, so they admit that of course we are far away from a single set of laws for all sciences, that we can scarcely go logically from physics to chemistry, but we are closer to those still far enough from more limited ideals of the unity of science, unity on the basis of terms or of methods. There have been relatively successful attempts to create a common body of terms for the sciences, so that the proposition of one science can be meaningful in others. It is possible to approximate a statement of the most general method of science so that they are applicable to all sciences. So right now we are far away to make general laws which of physics, which would automatically or naturally make us arrive at the laws of chemistry. Yet there are attempts made to create a body of terms which would be the same for all sciences, and there are attempts being made on it. Then, and then the fourth quality of science, part of science, fourth part of the definition of science is that it is cumulative. It is cumulative. That is, the present knowledge of science. Science is based on the past knowledge. Now, again, this over here, I would refer at the place of science and liberal education. Which you have read, the place of science in liberal education by Burton Russell. We have read this chapter, and I hope you have understood that chapter. In that chapter, Russell had pointed out the advantage of science over arts. He had pointed out that how scientific knowledge is based on the work of all the preceding scientists before the younger one, and how science is how a genius in science builds his genius on the pedestal of his previous or his ancestors. And this is what, or at this point, we find an art student at a disadvantage, and that is why the art students, they are taught to appreciate the past artists, and work of any artist or work of any art students always starts from a scratch. So the writer says the writers say the science is cumulative in that present knowledge is based on past knowledge, even when the new supersedes the old. The realist freshman in an introductory physics course knows more about phases than Aristotle did, not because he is brighter than Aristotle, but among other things because of the work of Aristotle. Okay, so a science student would know more terms or scientific terms than Aristotle. But this would not mean that he's brighter than Aristotle. He's intelligent and he's more intelligent than Aristotle. It means that he has learned all these terms of science from Aristotle and other scientists who had come before him. Scientific conclusions, and then the writer says that scientific conclusions are tentative. Science is reliable and claims probability. Now, scientific conclusions you have read in the base of science in liberal education. The conclusions of science, the results which science draws, or scientific conclusions, they are not final. They do not claim to be ultimate. They always claim them to be probable. They are probable. They could be challenged by the successive or by the new scientists, and that is why scientific conclusions are tentative. They are not permanent. Now, science is reliable because of the same reason, because its conclusion change in a successive approximation of truth. It does not claim absolute truth for any of its conclusions, but only probability. Then another feature of science is self-corrective. Science is self-corrective. Science is self-corrective. Yes, science self-correctiveness. Now, there could be errors because the scientific conclusion may be erroneous. Okay, they could be corrected. How could they be corrected? Yes, we are told that science does not correct itself only by recognition of mistakes. Solving one problem opens a path to others, and they in turn may lead back to a reconsideration of the earlier problem. When we learn that something previously called an instinct, for example, is actually the result of cultural conditioning, we promptly ask whether the same is true of other instincts, and what we discover about conditioning as a result of this new inquiry may lead to greater understanding of the first instinct. Of course, errors in correction lead to new knowledge, to scientific growth. Now, science is self-corrective. More science would be required to correct the errors, and errors may last for years. And for example, the scientists, they had tried their best finding ways of transmuting other elements or substances into golds. It helped them find the science of chemistry. Okay, so wrong hypothesis rightly worked have produced more useful results than unguided observation. So science is self-corrective, and while correcting a mistake which may last years, alchemy or this effort of scientists to find to transform other substances to make gold. It took years. It could rather centuries for them, and during that period, they had arrived at a new science called chemistry, and this is very much linked with the scientific growth, because one error in science leads to or open up new pathways. It leads to more discoveries. It leads to more discoveries of truth. For example, when the definition or when the knowledge about instinct proved to be wrong, and we came to know that it is instinct is culturally conditioning. Then the scientists asked whether it was true of other instincts or not, and that's how a better understanding regarding instinct was made. Then uh, then the writers, they talk about the fact that we must never forget that ideas devoid of a clear meaning frequently gave the strongest impulse to the further development of science. And they say that truth is an ultimate value in science, but it is not. The importance of scientific idea does not depend upon truth. The importance of a scientific idea depends frequently enough upon its value rather than on its truth. Okay, so the real value of a scientific idea depends upon its value rather than on its truth, and truth is itself one value is a value in science. So. Moving on to the distinction which has been made between science as a product and science as a process. If we distinguish between science as a product and science as a process, we can see that as a product, science is a body of proposition about the world. What we value are answers, and what we want them to be true. But as a process, what we value are questions and methods with their attendant insight and new concepts. And the truth of the presuppositions on which questions are based may be irrelevant to the value of the questions themselves or of the concepts that go with them. Here, the chief values are those of stimulating and guiding further inquiry. So, distinction has been made. Science is a product. Science is a product. When we talk about science as a product, then we are talking about the propositions about the world. We want to answer the questions. Okay, for example, we want to find a vaccine for the COVID-19. Okay, and here we are concerned about a product. But when we talk about science as a process, then we could talk about we could pose. We are more interested in questions, in the methods adopted to find an answer to those questions. Okay, and then the conclusion remains important, but the value of method and the question remains there. Okay, so science is cumulative, and then finally the writer talks about superiority of science over art, the contrast of science with art, and he says that the cumulative character of science becomes clearer in contrast with art, which does not necessarily improve. Science improves, but not art. Every artist, no matter what he has learned from his masters, really starts from scratch. The scientific novice, young person, however, starts his thinking with the conclusions of the past science. Although he may correct some of it, he accepts most of it and goes further, and he enters the laboratory complete with instruments which his predecessors did not have, instruments making new and more exact observation and measurement possible. The artist has no such aid from instruments, for a typewriter will write no better sonnet than a quill, a feather pen. So, science is the writers have proved that science is superior to arts or the superiority of scientists or of a science student over an art student, or the privilege which a science student enjoys over an art student has been highlighted. So this is all for today's students. I hope you have understood today's lecture, and please do write down the summary of this chapter, and try to make a comparison between this chapter and the chapter the place of science in liberal education. Write down the common features of these two chapters. Good luck.